Okay, so we'll do a brief kind of introduction, I guess, in terms of the work that Kamal and I have been doing. So we're coming from Boston currently. Actually, we just previously came from Amman teaching a workshop, which we'll talk a little bit about. But we kind of span a few different worlds. Right now we're at the MIT Media Lab. I'm pursuing a PhD there, and Kamal is actually doing research. We're both part of the Changing Places group at the MIT Media Lab. So the Media Lab itself is kind of an amazing place with a diverse array of interests. There's actually 27 different labs at the Media Lab, and each looks at totally different areas of interest. So we have groups that are working on biomechatronics, so prosthetic limbs for amputees. And at the same time in our group, we have people who are looking at different technologies for cities and looking at the future of cities. So I've been there for around 2 years now, and Kamal's actually just starting. Yep. And we also teach a workshop that we've been teaching for the past 5 years at Columbia. And we're both actually master's students. We graduated with a master's degree from Columbia as well in architecture. And so that's kind of our involvement with Columbia too, which spans into many kind of diverse areas of interest. So we're glad to be here tonight, showing some of the work that we've been doing with Columbia, and also showing a few of the research projects that we have that we're currently working on with MIT and things on the horizon.
So with that, maybe we'll begin.
And if people kind of peter in, we can, you know, of course, questions at the end as well. So some of you may have seen this image. Upon first notice, it might look like a suitcase, but we would actually argue that this is more than anything our office as of late. You notice a bunch of Arduinos inside, a bunch of cords, computer. And actually, part of the reason for this is that the way that we work increasingly more and more is in this mobile kind of way, very adaptive to the places that we're actually working in. So sometimes it's a little bit difficult for us to get through security at the airport, and as our participants in the workshop can attest to, because they've now experienced this as well, sometimes we get stopped. But ultimately, it adds to the experience, I suppose. So really, we're looking at kind of adaptive technologies for cities and the future of cities and changing cities. So cities are not static. They are dynamic entities, constantly changing, constantly evolving. And we're interested in looking at cities as adaptive technologies, as this kind of ever-changing technology. So tonight we're going to talk about a few different projects, actually 4 areas of interest that we have. The first being why we're actually here tonight in Istanbul, which is for the public space workshop that we're teaching with Columbia. So that's a focus on public space in cities. The second area of interest, we'll be looking at energy in cities. The third area we'll be looking at mobility. And the fourth is food in cities. So that's kind of vast and broad, but we'll try to kind of narrow those areas with the projects that we've been particularly looking at.
So for the first project, Public Bit, I should first introduce that for us, we research by doing. And without that, effectively, we don't have anything to judge kind of our ideas by or to actually test them in the field. So the Public Bid is really the culmination of a 5-year-long experiment that we've been conducting at Columbia University in the form of the Public Space Workshop. And the Public Space Workshop is significant insofar as it really sits outside any kind of formal educational boundary within the school, and it does so within the Studio X network. As such, we have access to many different nodes within Studio X, and for the first 3 years we were in Amman, as you can see from this diagram, and in the last 2 years we've traveled here to Istanbul, and we're actually very excited this year to be continuing the experiment in Mumbai. So this is a live experiment at the moment. We're here working. Many of our collaborators are actually in the room. Sorry, can you hear me now? And it's a growing network of collaborators, which is what's exciting. And so as you can see, really we started off sort of modest in the beginning, but this continues to grow, and increasingly collaborators from past years are actually coming back in and feeding into the workshop idea. And so here you can see a workshop that takes place in 3 cities is rather complex just in the very nature of it. And as Jennifer was describing, when you really consider cities as adaptive technologies, you also have to operate at the pace of those cities. And that's why, for us at the moment, the suitcase is really the best format to pursue it. We're largely concerned that architectural practices and design practices are slowing, and in fact the development of these cities, as you've seen for instance in the examples that Rajiv discussed, are actually vastly accelerated, and so it's a constant race to kind of keep up with it and being able to insert a project or actually test a theory with the city as your lab in a kind of real-time way. And so that's what the public bit tries to approach. So basically, to do this and to reinforce the idea of working in a mobile way, everything is made public as we do it. So collaborators from many different countries descend upon a city. Here in Istanbul, we have 3 different countries represented. Everyone works in a team. The teams are made up of kind of diverse backgrounds, largely in the design fields, and everyone works with mobile tools. So everything from a laptop to a phone to whatever you can carry with you as you're going into the city. On the website, you can find the components for actually assembling the public bit, all of which are based on open hardware and open software elements. And then these can be assembled and reconfigured in the ways that best suit the teams doing the research. And so what you have here as a foundation is the Arduino unit, which is, for those of you who don't know, essentially a microcontroller to which you can connect various sensors, battery packs to ensure mobility, wireless Wi-Fi routers to carry with you, anything that you need to be a kind of connection point in both the virtual network as you're navigating kind of physical networks in cities. So that's available to you, and we would encourage you also to check this out. Additionally, there's an ongoing dialogue which happens online as well. This is fed not only from our collaborators, but also audience members who see the work, interact with it, have questions, and so on. So the way that this is all kind of comes together is rather simple. There's the hardware unit, the software unit, which is essentially telling it what to do, and then it's deployed in the city. And so it's deployed to great effect because our collaborators, our participants in the workshop, are really looking at kind of specific areas in the city in terms of what makes them public space. And they do this in 2 ways. One is actually sensing the various qualities of what a public space is. Some of those imperceptible to us as users, others rather obvious, but worthy of documentation. And in another way, they're also looking at how you can actually activate those public spaces, which is altogether a different operation. And so here you really begin to see the relationship of input and output as mediated by something like the Arduino in the form of the public bit. So just a brief example, and again, this is from Amman. You'll see the Istanbul examples tomorrow, because they're currently being cooked in the kitchen, as it were. But basically, the proposals are put up online in a very public way as the teams are working. We can go to the next one. And then the feeds, the actual live feeds from the public bits which are deployed in the city are also broadcast online. And so you can very quickly see, and this is a kind of lighting levels, what is happening where it's deployed in the city. It's actually geolocated. You have the code, so you can also replicate it yourself. And this continues throughout the 3 cities. So ultimately, we have a kind of dashboard of performance in public space that you can get across 3 different cities. A rather interesting comparison, and accessible to anyone again. So kind of a critical point. And this reinforces a concept that's integral to the public space workshop, which is that we view this space as a resource for cities. In fact, it's a uniquely kind of urban condition, as you've experienced quite intimately here in the recent weeks. It's a place of exchange. It's a place where public opinion is actually formed. And so the communication for it, and in fact the vehicle for it, in which to transmit this public space is of the utmost importance. And that's why the sort of reliance on openness, open technologies is key. And just a sense of the ambiance of the public space workshop, we all work around one table. Each of the teams are focusing on different areas, but it's very much in the spirit of collaboration that a lot of the knowledge transfer happens along this table. You can see there's a direct relationship between the design and the implementation. We work very quickly, so we're typically about 1 week in each city. There's very little time to do much thinking, as it were. It's a lot more doing and testing. And then, you know, from time to time, we get out to enjoy the city.
And so maybe we'll also close with tomorrow at 4:30 p.m. The students and participants of the workshop will actually be showing their work at SALT. not in this space, but in the sister space. So if you guys are available and interested in seeing what everyone's been up to during the course of this workshop in Istanbul over the last week, we invite you all to come by and actually check out the work. So the next project that we'll look at looks more specifically at energy in cities. This project is the personal power plant. One of the things, especially in the US right now, a lot of people are looking at the kind of aging infrastructure in the United States, and specifically energy infrastructure in cities. What we're finding is that 99% of basically power grid or power failure actually ends up happening on the power grid itself. So this has happened from years and years of constantly adding new kind of pieces to the grid. Everything's kind of fragmented and separated, as you can even see here. So this is kind of an aging infrastructure that's very hard to kind of readily adapt and change. So one of the questions that we had was, why is power always tethered to a particular place? Why is it always something that you can't kind of distribute or change? And today, you know, all of us have our cell phones in our pockets, mobile applications. How come energy can't act in this kind of way? Much more mobile, much more easy to use. So we're kind of stuck in the Stone Age with our energy, that it's constantly kind of being plugged into the wall in order to be utilized. So the personal power plant, much in the same way as the public bit project, is actually devised as a kit that people put together. It includes a number of components, including a solar cell, a hand crank, which uses actually some components from Legos as well, its own kind of circuitry. It has a battery, a rechargeable battery that you can continuously recharge over time. And the idea is that you can use this as kind of a portable technology for harnessing energy that can be used for any application. And basically, for the purposes of this, we had it as a USB portal, so you could actually charge your mobile devices or anything else USB related. But really the idea was to create this kind of platform for people to decentralize where their energy is actually coming from. And obviously we know, we're not saying that all energy can come from a hand crank or a solar cell, but it's a different kind of way of looking at energy and understanding energy and where it comes from. And that also it can be a participatory process. So oftentimes we find that people forget, because the infrastructure that we constantly tap into is, you know, underneath our floors and in our walls and underneath the street. We forget what that infrastructure means. And I think especially last week in our own workshop in Amman, we started to learn how dependent we were even on the internet as a technology, and when it doesn't work and when it doesn't function, that's when we actually end up noticing it as an infrastructure. So this project wasn't something that just, you know, happened once. There were actually a series of iterations of this project, a number of different versions. And actually those versions came out of a series of participatory workshops where people learned how to put these kits together. They learned how to solder, they learned, you know, basic electronics, and they put them together anywhere from the ages of 5 to, I think the oldest participant was in their like late 60s. So this is all ages, and people would come with their kids. People didn't come with their kids, but the idea was to make it as accessible as possible. And so normally when we think of electronics or anything in this kind of manner, we see these diagrams like this, these circuit diagrams, which are interesting and obviously very useful. But the problem is they're only accessible to a certain group of people who know how to decode them. And so one of the things that we also did with this project was look at how we make those diagrams, those tools, more accessible to a broader group of people to be able to share them. So this literally is a circuit diagram drawing basically the exact same thing as this, but in a physical manner, so you can actually start to see how things are wired. And that was like kind of a huge breakthrough. And now more and more fritzing is being used. I don't know if anyone's used some of those tools before. Also an open hardware tool where you can basically input your own circuit diagrams, and some of the participants in our workshop now are using this. So another important feature of this project is that it was something that we also wanted to make open, and we posted this on a site called Instructables. I don't know if people have used this here, but if you haven't, you should check it out because it's a really awesome site. But basically, this is a repository for people who are just doing really interesting projects that they want to share with other people. So you post them online, you post how to make something, kind of a series of steps, and people make them, and they also add to them. They add to them through the process of actually making. So this project actually, as I mentioned, is an ongoing kind of project with a series of iterations. I mean, this page alone, I think now it's even higher than this, has like over 100,000 views. Obviously not everybody made it, but a lot of people did make it, and a lot of people actually sent images back of how they were using it. Some people attached it to their bicycle and started riding their bicycle and storing energy from it. So those things are really kind of powerful and impactful when you can share those kind of tools with people and have them participate and add to what you've already started with. So this is one of the images from the workshops. As you can see, people of all ages kind of learning how to do these things, learning to solder completely from scratch.
So Open Mobility is a new research project that we just wanted to introduce, but it's a collaboration with Ford Motor Company and the Media Lab. And really what it looks at is the nature of mobility in cities. Ford Motor Company has recently launched an open source API called OpenXC, which essentially allows third-party developers to access the sensor data which is in vehicles. So the average vehicle has about 75 different sensors, everything from status monitors, so on and off of your car, to air quality. And the question becomes, when you couple that with the increasing intensity of mobility in developing cities and open data which is provided from cities, what happens? And I think what we start to see is that, in fact, your circulation in cities is much more than just a point A to point B sort of decision, but in fact it's an accumulation of a whole series of decisions that possibly reveal a lot more, not only about the city, but your preferences in terms of trafficking through it. And so this is a project really just at the very early stages, but it's looking at, in fact, those networks and the networks that support it. And like in much of our work, we're interested in the role that technology plays, not only in facilitating access to those networks, but also to expanding it. And in this one in particular, there's a clear kind of spatial relationship in terms of what you have access to as to where you can go and how you can engage with the city. So hopefully we'll be back soon to show you some of the development. But for us, it's just another kind of important issue in terms of the way that we work and what we're interested in cities, that mobility itself is now being evaluated as a tool for how you can actually do these things.
So the last project that we'll chat about tonight is called Sprout.io. And this project specifically looks at food in cities. So this is a kind of a common image and a common landscape that we're seeing more and more today, which is kind of vast swaths of land being industrially farmed, basically since the 1940s and the kind of green revolution, where we basically took over fields and just farmed one kind of crop, whether it's corn or soybeans or what have you, basically changed the landscape of food production in general. What a lot of people are surprised at is that oftentimes food, when it's discussed, it's like we don't have enough food globally. We don't have enough food worldwide. The real issue is that we're just not very efficient at how we actually distribute the food that's produced. So as you see in this diagram, in 2008, we actually produced enough food to feed 11 billion people, and the population is actually 10 billion people. You'll notice on the left-hand side, about 1 billion of those people are hungry. Another billion are actually overweight. And about 4 billion, which is about a third of that supply, was wasted due to supply chain inefficiencies and the process of getting that food from the farm to the consumer. So, of course, the most kind of important aspect of this in terms of looking at our daily diets and the things that we should be eating. Most of us probably don't eat nearly as many fruits and vegetables as we should, especially in the US. This is a huge problem with obesity and people who are eating more kind of processed foods, foods that somehow in one way or another involve corn in them. But really we should be eating around 50% fruits and vegetables in our diet on a daily basis. But what ends up happening with this food waste that we're getting, because fruits and vegetables are the most perishable items, we end up losing around 50% of those fruits and vegetables going from the farm to the consumer. So you can kind of see this process along the line, and actually a huge part of that issue is even at the consumption level. And I know many people end up throwing away a lot of their food just because it has a small bruise on it, or, you know, people end up throwing food away and wasting it. And actually, I would argue a large part of that is because people don't realize the process that ends up going into getting their food to the table. So what ends up happening in this process is that you have people who are consuming all of this food but have no conception of how that food is actually produced originally on the farm. A lot of times we end up getting this kind of packaging that has a very pictorial aspect on it, showing, you know, the happy farm animals in the background, and, you know, it's very pastoral. And in the end, that's really not the way that food is actually produced and distributed today. So we argue that people need to look at different ways of growing food for cities, different types of technologies, just like industrial agriculture is a type of technology. People often forget that. We need to look at new types of technologies for growing food in cities. And so the Sprouts.io system is actually a concept in which people are able to grow food in their own homes. We want to bring food closer to the consumer, the production of food closer to the consumer in the end. Now, there are some things that are available now where people can grow here and there on a hobby level, which is wonderful and actually is great. But the problem is people can't grow a substantial amount of food. And if you ask most people, do you feel comfortable actually growing food for your family? Would you feel comfortable growing enough food to support your family? Just about every person I ask is like, what, are you kidding? No way, absolutely not. And a large part of that is because we're so kind of divorced from our food and our food processes, we don't even know how to actually grow anymore. And so the idea is to bring this back into the hands of people in urban areas. So the idea is to, within a small, very small space, even an urban apartment, allow for people to grow a substantial amount of produce. And that also is organic produce. So the way that we do this is by using a technology called aeroponics, which some of you may have heard of. The idea is that basically you're misting the roots of the plants with water and with nutrients. There's actually no soil in the system at all whatsoever. There's a lot of plants that actually grow in nature this way, and it's possible to grow just about any plant you want aeroponically. The key part is that you have to provide enough water for them, enough mist, and the proper nutrients for the type of plants that you're growing. So this is kind of an up-close shot of the Sprouts.io system currently, which is a prototype, and how you would actually plant the system. And then inside each of these growing chambers is the actual aeroponic mister component, which keeps each of the pods that the plants grow in separated from one another. There are many benefits to growing aeroponically, actually very huge benefits that end up kind of affecting a larger portion of a lot of different areas in terms of energy and even water use. But specifically with water, with aeroponics, you can grow with 98% less water than you would use in a soil system. So this is really important when you consider that about 70% of our water currently, our fresh water, actually goes to industrial agriculture. This is a tremendous amount of water. I don't think people even understand how much water that is. So more and more water is becoming like oil in essence. Is a very valuable thing. A lot of countries are even fighting over where they're getting their water from. So being able to grow a substantial amount of produce with so much less water is a really important aspect of the project. Additionally, growing in this method, you use about 60% less fertilizer in growing the plants. It's also a pesticide-free system. You can grow inside, and as I mentioned, these growing chambers are separated, the roots are separated from one another, and that actually assists in growing the plants in a more kind of sterile environment at the roots, which is where a lot of the disease actually comes from. It's also around half the growth time per cycle with aeroponic growing, so you can grow plants much more quickly. It's also very lightweight. So soil system, it's around 120 pounds per cubic foot. Sorry, I can't translate that into metric right now. But that's very heavy. So talking about trying to do something like soil growing indoors is just not a very realistic solution at all. And additionally, people don't really want to have dirt inside of their homes. So also, because you're growing in a controlled environment, you're actually able to grow all year round because it's growing indoors. So you can get around 6 times the harvest within the same area. So just quickly to look at a comparison to give you an idea of what the numbers are in the end. If you're growing in a soil system within 1 square meter, you can produce over a year-long period. This is actually looking at 365 days with 10 different types of fruits and vegetables that you can grow in the system. You're getting around 23,000 calories annually. So that may seem like, okay, that's, you know, good amount of calories. But when you look at an aeroponic system, within that same footprint, you can actually produce around 5 times the amount of produce. That's a drastic change. And in soil, of course, you're only growing on the ground, right? But in an aeroponic system, I can tier it. So as much space as I have or as high as my space is, I can tier the levels. So I can effectively greatly increase that, dramatically increase it. So even within this space, we're estimating that for one person's yearly fruit and vegetable intake, we could actually grow within 1 meter squared area, which is very small. So another important aspect of the system is making it as easy as possible for people to start growing immediately. So one of the impediments now currently in trying to grow with these methods, even with hydroponics, which is where the roots are fully submerged in water and is a bit more maybe known way of growing. The problem is a lot of these things are kind of piecemeal components. So I could go to 10 different stores and get all of the components that I need, but then I need to go online and look at, you know, people who are growing it, and I need to look at like 10 different sources to get all of those ideas put together to finally actually start my own system, which then I need to build. And so people don't want to do that. It takes way too much time, way too much effort. And the idea is to create a system that I would say, I always say it's like IKEA, but I like to say it's actually much easier than IKEA because you don't have those frustrated diagrams of the guide putting things together. But so the idea is within 10 minutes you can basically have your system up and running in your home. So it's a modular system with components that can be easily taken in and out of the system. Also important is to think about even the maintenance of the system. So if it takes a person more than 5 minutes each day to care for this thing, it's too much time. People don't want to spend tons of time doing this. They want to spend some time, but you don't want to be cleaning your system for hours every day. So the idea is even the pods themselves, you can take them out and put them into your dishwasher. So it's very easy to kind of maintain. Additionally, the system even looks at design in terms of the plants, how they grow over time. So most systems, you actually can just plant the seeds in one area and then you have to transplant them a number of times. And that's problematic because oftentimes your plants aren't happy when you do that. So in this system, you can grow throughout all phases of the plant cycle. The system also incorporates sensors to tell you what's going on behind the scenes with your plants. You hear people in the background. Ooh. Should I continue? Okay. So the system also incorporates sensors. So it has a humidity, light, pH, and temperature sensors to tell you what's going on behind the scenes with your plants. So I often say, like, I am terrible at growing orchids. I've tried for years and years to grow them. I wish that I could because I love them and I buy them all the time. And they're never happy when I buy them because they never really last for very long. But if I knew what I was doing wrong. If I had something that could actually tell me, hey, like, you're watering them too much, you need to provide, more sunlight or less sunlight, it would help me a lot in how I'm actually growing my plants. So the idea is that all of these sensors are kind of feeding into a database that gives personalized recommendations on growing your plants. So as I mentioned before, a lot of people are kind of intimidated by growing their own plants or feeling like they can grow their own food. So the idea is that this database over time actually becomes more and more fine-grained with the data that it produces or it collects, and that you're able to share these data profiles with other people. So let's say you grow spinach really well, and I want to grow spinach. I can actually swap with you. You can send me your information, your data about your plants, and I can try to emulate that in how I'm growing my plants. So the idea is to create kind of a community of growers that are able to share information on how to grow their plants. Additionally, a really important feature of the system is that it is automated, or certain aspects of the system are automated. So right now, if I'm in Istanbul giving a talk and I have my plants growing in my apartment in Boston, I can actually control my system from afar, tell it to turn the lights on, tell it to mist the plants on a schedule as needed. So it's electronically kind of extending that green thumb. So we see the idea for this is, it's interesting if, one or two people have this, okay, that's, kind of a cute thing, but when thousands or millions of people within a city start growing in this manner, start sharing information, start even sharing their food with one another, become more attached to how their food is grown, more involved in the process and the cycle of growing food, that's when we think we can actually impact and change the way that food is produced and distributed in cities and involve people in that process. So that's kind of what we're trying to do with this project. Trying to save the whole food industry in one project.
So in these 4 examples, it becomes clear how important the role of networks plays in our work, whether it's through the distribution of energy, either in the form that we consume in terms of the Sprouts IO, or the kind that we generate on our own to power the devices that allow us to extend our activities and do the things that we enjoy doing, to the very way that you could actually work in a kind of mobile manner to kind of keep up with the changing pace of development, or in fact the nature of mobility and what that reveals about our use of the city. If nothing else, we've had to adopt a way of working that allows us to actually engage with these changes in a more dynamic way, such that we're able to respond at the time, which is where these changes are happening. And so this is the way we open our office every day, and hopefully more of you will start to open your office in a similar way as you start to engage with the city. So thank you very much.
So we'd love to take any questions that you guys have.
Sure.
Yes.
I'm sorry, the terms are very new for me, so I may mispronounce them, but when you were talking about aeroponic?
Aeroponics,
okay.
yes.
Anyway, the only component that you didn't talk about was the nutrition the plant needs. So where do you get that? How do you extract that? How much energy consume when you extract that nutrition that specific plant needs? And who sells it, and how expensive?
That's a lot of questions in one question. So yes, basically with an aeroponics system, you can provide, a lot of people ask this, whether it's the same kind of thing as growing in soil. Soil has a series of different types of micronutrients in it. And those nutrients can actually be extracted and can actually be provided aeroponically to the plant just as easily. A lot of people are like, well, soil, how come, soil is such a, it's, has all this infrastructure in it. A lot of people talk about growing in soil and it being this tremendous thing, and it is a tremendous thing actually, but at the same time, if you're growing in soil that has tons of fertilizers and pesticides on it, then that's not really a great solution to actually growing in soil, and a lot of people end up not realizing that that's currently how we end up actually growing in soil. So you can, aeroponically, there's actually a lot of people who are doing research on this. There's a gentleman who's actually an advisee for this project. His name's Richard Stoner. He's been doing a lot of work with NASA on developing specifically technologies for aeroponic growing in space. And initially when they started doing this, a lot of it was, you know, there's no water in space. What happens if we need to grow food there? So that was a lot of the research. But actually it's very possible to grow aeroponically and provide the proper nutrients for your plants. In fact, you can even provide more kind of tailored nutrients for your plants based on what you're growing.
The other environmental advantage which should be noted, particularly when you're considering it from an urban perspective, is that nutrient depletion in soil is actually alleviated because they're grown in these isolated pods, and it's basically a nutrient bath that's misted to the roots of the plant. The various kind of nitrogen fixing cycles that go on in the soil, and the adverse effects of various fertilizers and so on are completely avoided. So you bypass that with this system altogether. Yeah.
Any more?
Sure.
Yes.
So can I ask something about of the idea of this plant growing thing? If we just start to grow our own plants in our own homes, isn't it just running away from the this weird process of from production to consumption, and also just running away from the problems of wasting foods and etc.? Because if does people start to make their own plants in their own homes, even not without caring and spending anything over them, not even 5 minutes, we are just running away from the problem of the rural areas and the problem about this waste of food and the distribution problems, and also from production to consumption.
So I think it's important to note with this project that the idea is to, it sounds romantic to say that this project is going to change the entire food system. I'd love to think that it could. I actually have dreams that it could do that. But we're not saying that the process of distribution for the current production of food is okay and should stay the way that it is. And I think that that's something that needs to be addressed. And currently right now we're incredibly dependent on the way that food is grown with this industrial process. So it doesn't mean let's remove industrial agriculture, but I think the point right now is that people don't understand there are other methods that could be looked at, other kind of technologies, other kind of ways of growing other than what we have currently. So I think that there's kind of a whole new discussion around this area, which I hope really even spreads further and further, which is more people thinking of ways to be creative, thinking of ways to kind of intervene in this process. And hopefully, if we have enough people thinking about this as an issue, we'll be able to change the way that things are currently happening. However, I think that the idea of people being more in touch with their food by growing it themselves is actually a really important aspect of the project. I'm not saying, you know, by growing in the system, people don't spend time with it at all. I mean, they do. It's grown in their homes. But the idea is that when you think about farming and people think about farming in their homes, it seems like this really laborious task. And generally, if you think about growing, it can be. So part of it is convincing people that, hey, you know, you can grow in your home. It can be something that doesn't take your entire day up. And also you can share in that experience with other people and share that food. And I think most people know, like, you know, if you work on a project and you're invested in something, then you care about it and care what happens to it. In the same way that if you grow in your home and you're growing your own food, you're invested in that food. Like, I know my mother used to grow tomatoes in her garden because we actually had space to do that. I lived in the suburbs. And not one of those tomatoes was wasted. Every one of those tomatoes went to one of my family members that lived somewhere. They were, you know, I was taking them to my cousins so that they could actually eat them. So it was because she grew them. And so if people start growing themselves, they'll have that kind of investment in the food that they're growing.
So that's key at the point of the end user. But then if you look at the whole model, what this project proposes is really a kind of revision of that. So whereas 50% of the produce is actually lost in the distribution from the farm to the city, Sprouts.io proposes that you actually take one of the great assets of the city, which is increased density, and redistribute the farm in small, manageable ways to the actual end user. So you cut out that whole supply chain, you localize it with the person consuming the produce, and in fact you create a more efficient cycle for that. And so it's one way of thinking that in fact, because we are connected, because the sort of appliances, products, spaces that we are also feed into these networks that facilitate the connection, how can we rethink some of these problems now in cities to kind of alleviate some of the damage that we've done, right?
And one of the things that we often think about with this project is the potential for it to become ubiquitous in the home, to become an appliance. So, you know, over 60 years ago, when people didn't have refrigerators in their home, they had an icebox, or not even before that. Refrigerators seemed like, why would you, that's crazy. But then it became something that was standard in the home, whereby people could actually have food in their home for a period of time and waste it less. So that was one good thing that refrigerators did, for sure. But then why not grow food in the home? Why not? I mean, what's the leap to actually do something like that? So I think when something like Sprouts.io or whether it's Sprouts.io or something else, but the idea of this becoming something that's integral to all of our lives, our daily lives. You know, you wake up in the morning, you brush your teeth, and you check out your Sprouts.io system and make sure that your plants have enough water. At night, you come home, you make a salad, you cut off the leaves, and you're eating fresh fruits and vegetables that are organic and that you grew and know how they were grown. So, yeah, I think the potential for that is really kind of exciting. Yeah.
On this point, is there any research in terms of making this available to the farmers as well on that scale? Because I mean, I kind of disagreed with the comment about, you know, whether this is turning our back on the system. I actually think it, like you said, it provides a kind of a value system. And the other thing is in India, what's happening, for example, with the farmers and the urban areas is that farming is slowly being taken over by certain corporations, which are systematizing and industrializing that product. And now there's a large movement which is going back to organic farming. So there's a lot of organic farming. The problem is that the amount that's produced is actually less, but it's more higher value.
Right.
And the other thing is the amount, there are many places within the rural areas which don't have water to actually farm. Right. So you have to actually make a system which provides, you know, exactly what you're saying. It alleviates certain issues which are integral to the process itself. I mean, I don't think it's turning back. It's really might solve the problem, maybe not initially, but in the long term, it sounds pretty interesting.
Yeah, organic produce, it's a funny thing because now more and more people want organic produce, but the problem actually is that we can't supply organic produce with the way that we're currently growing in. So it's actually one of the largest areas of consumer spending that's increasing and increasing, and we can't actually farm enough for it. So doing something like this offers kind of a viable solution for organic produce, and it's actually much more cost effective as well. Any other questions? No? Oh, Q?
Hey Jenny, how big is the prototype scale that you have worked in so far?
So I can't, in meters, I don't know if I can convert that, but basically it's 2 feet by 2 feet by, right now it's 4 feet.
For how long have you grown in that patch?
Basically the testing started this summer, and we're still doing testing on it, but around that period of time, basically for a month-long period.
Okay.
I think there was one more.
I'm from Australia, where a vast majority of people have their own gardens, excuse me, but they still can't be bothered to grow anything. And one excuse they give is that because it takes too much time and so on and so forth. And a lot of big supermarket chains actually use this, come to our supermarket and just buy it. So if this idea really, really takes up and millions of people start using it, like how do you think, or do you think big supermarket chains will try to kind of attack this product in some way?
I don't know about attacking the product, maybe. I mean, I think by the time that happens, hopefully other things will have gone on in the process. But no, I don't think right now the idea is to take over the current like grocery stores, or, you know, I think right now it's a proposal to think of food in a different way. But I do think that the potential is there if enough people are using it, if it's easy enough to use, that it could. And in essence, then I would say the grocery stores need to figure something out. Like, that's their problem, not mine.
Sure.
Excuse me. Thank you. I really like the comparison to the refrigerator and making it a ubiquitous thing in the home. Have you calculated how much space you would need, say, for a couple in a tiny studio apartment to actually provide all the food you would need, or all the produce you would need, given nutritional guidelines and all that?
Yeah, actually, one of the slides that we showed was showing kind of a calculation of a square meter area. With the system right now, that would basically be like having 6 tiers to the system. Our current prototype only has 2. But if you had 6 tiers to the system, you could effectively provide enough produce for 1 person. So if you had 2 systems, then you could, obviously it's kind of 1 per person. So,
and in a such a controlled environment, is there a seasonality to the produce?
So one of the things that also I think people are like, really, there's no season for this, which is sometimes seems a little bit strange, is that, yeah, basically you can grow year round in the system. So currently the design incorporates LED lighting. Ideally what you would be using is, if you're in an apartment and you have a window, you should use your window because it's free lighting, and actually sunlight is really kind of the best scenario. But it's augmented by LED lighting as well, which a lot of people also ask about the energy for LED lighting, which I think now more and more this kind of stuff is going to happen, because we're at a point where we're at the tipping point with LED lighting where it's efficient enough that we can actually produce a substantial amount of light for very little actually energy input, because the LEDs are around 50% efficient. Or I don't think those are out on the market yet, but we're working with Sylvania to develop lighting for the project. So
additionally, operating at a certain scale with the Sprouts hire, you can imagine that the markets that currently exist, which are importing produce out of season into markets, would be reversed, right? Because you could, for instance, if you were growing tomatoes in the winter, do that within the controlled environment of your home and no longer rely on sort of importing tomatoes from another hemisphere in which they're in season. So that extension, I think, to the earlier question about the relationship to the farm also extends and actually starts to impact the produce market itself, because you're no longer relying on that. Great. Well, thank you very much.
Thanks, guys, for coming out.